So, hello everyone, this is Hymavathi, working as an assistant professor in the Department of Humanities and Science, so MLR Institute of Technology. So, in the last session, we discussed about the particular integral of method 3. So, today in this session, we will discuss about the particular integral of method 4 and we will see the problem on finding the method 4. So, what's a method 1? The method 1 is a q of x is equal to q of x, that is the type 1. And the type 2 is sin ax or cos ax. And the type 3 is a polynomial. So, these are the three methods already we discussed in the previous sessions. So, now we will see the what's the method 4 of by finding a particular integral. So, the method 4 is when q of x is equal to e power ax into v of x. So, here v of x is any function. So, but here mostly we are taking the v of x is a polynomial or sin ax or cos ax. So, we are taking only these two functions and then we are finding the particular integral. So, if it is e power ax into v of x, then how can we find the particular integral? The yp is defined, so we know that what is the yp defines 1 by f of d into q of x. So, here the q of x is nothing but e power ax into v of x. So, first you have to this e power ax apply on f of d by taking the substitution d is equal to d plus a. So, what is the yp? So, yp is nothing but 1 by f of d e power ax into v of x. So, first you have to apply this e power ax on f of d. So, by taking the substitution d is equal to d plus a. So, then what is the yp after taking the substitution? So, after applying the e power x, then right before, so e power ax into 1 by f of d plus a into v of x. Suppose if v of x is sin ax, right? So, if v of x is sin ax, then you have to apply method 2. Apply method 2. Or if it is a polynomial, x to the power n. If it is the polynomial x to the power n, you have to apply. So, if it is a polynomial x to the power n, then you have to apply method 3. So, again we are using either method 2 or method 3 that depends on the given function v of x. So, this is the yp when q of x is equal to e power ax into v of x. So, what's the substitution to take? So, the substitution is d by d plus a. That is the substitution to take. Then after that you have to use either method 2 or the method 3 when q of x is or the v of x is a different function. Sometimes sin ax, sometimes a polynomial. Right. So, now we will see the problem on this method 4. Solve d power 4 minus 1 into y is equal to e power x into cos x. So, clearly the given differential equation is of the form f of d into y is equal to q of x. This is clearly non-homogeneous linear differential equation with constant coefficients. So, now we have to find a general solution. So, to find the general solution, so we have to find a complementary function and a particular integral. So, first we have to find the complementary function. So, to find the complementary functions, so we have to take the auxiliary equation. So, the auxiliary equation is f of m is equal to 0. So, we know that what is f of d is d power 4 minus 1 in d you have to take by m. So that is m power 4 minus 1 is equal to 0. So now to find the roots, this can be taken as m square whole square. Then this one also can be taken as 1 square whole square is equal to 0. A square minus b square, this is of the form a plus b into a minus b. So that means m square minus 1 into m square plus 1 is equal to 0, right? So now here on m square minus 1, so the roots are m is equal to plus or minus 1. So for this m square plus 1, the roots are plus or minus I. So here we have totally the 4 roots. So for this 4 roots, we have to write a complementary function. So the complementary function yc is equal to, so first write the complementary function on the real root and on the complex roots. So again, I am writing here the roots clearly, the plus 1, minus 1, I and minus I, or plus or minus I. Simply we can write this as plus or minus I. Plus or minus I. Right. So first these two are the real roots. For the real roots, the complementary function is c1 e power x plus c2 e power minus x plus, next we have to write the complementary function for the complex root. If it is a complex root, what is the form? We know that already the form of a complex root, right? So if it is of the form alpha plus or minus I beta, then the complementary function is yc. The complementary function is e power alpha x into c1 cos beta x plus c2 sin beta x. So this is the way to write the complementary function if it is a complex. So here there is no alpha, which means 0. So e power 0x into, so already we have taken two constants as a c1 and c2. Now we have to take the c3 and the c4. c3 cos, here the beta value is 1, cos x plus c4 sin x. c3 cos x plus c4 sin x. So this is the complementary function for the real root and for the complex roots. So now to find the yp. So to find the yp is equal to 1 by f of d into q of x. So here the q of x is e power x cos x. 1 by f of d is nothing but d power 4 minus 1 e power x into cos x. So now this is of the form is, this form is e power ax into v of x, where v of x is cos x. So if it is the cos x, definitely we have to use the method 2. So first, before applying the method 2, so first we have to apply the method 4. So what's the substitution to take here? So here the substitution is d is equal to d plus 1. So what is the coefficient of x here? 1 is a coefficient, so that the substitution is d plus a, right? So a value is here 1, so d by d plus 1. The substitute d by d plus 1. So after substituting d by d plus 1, and again you have to write e power x before, e power x into 1 by d plus 1 whole power 4 minus 1 into cos x. So now we have to write the value of d plus 1 whole power 4. So this is equal to e power x into 1 by d power 4. So by the expansion we can write, or the other way is to find out this is, you can split this as d plus 1 whole square into d plus 1 whole square. So we know the formula of a plus b whole square by taking the product. So by taking the product, so it will give d power 4 plus 4d cube plus 6d square plus 4d minus 1. So d power 4 plus 4d cube plus 6d square minus 4d plus 1 and minus 1. So this is the whole expansion value of d plus 1 whole to the power 4. So into cos x. So here the plus 1 and the minus 1 is gets cancelled. So e power x into 1 by d power 4 plus 4d cube plus 6d square plus 4d into cos x. So now this is converts to the method 2 of finding particular integral. So this is of the form 1 by f of d into v of x, where v of x is a cos x. Now we have to use the method 2. So what's the method 2? Here the substitution is d square. D square is equal to minus 1 is the substitution. So d square is equal to minus 1. And what is the d power 4? D power 4 is nothing but plus 1. So now we have to substitute that one. So e power x into 1 by d power 4 value is 1 plus 4 into this d cube can be taken as d square into d. So d square is minus 1. So one more d we have plus 6 into d square is minus 1 plus 4d into cos x. So now we have to simplify this. E power x into 1 by 1 minus 4d minus 6 plus 4d into cos x. So here this 4d and minus 4d gets cancelled automatically. So denominator value is 1, minus 6 is there. 1 minus 6 is nothing but minus 5. So 1 by minus 5 into cos x. So this is the yp. So now we have to write a general solution. So now the general solution is y is equal to yc plus yp. So now here the complementary function yc is nothing but c1 e power x plus c2 e power minus x, e power 0x, anyway we know that e power 0x 1 plus c3 cos x plus c4 sin x minus e power x into cos x by 5. So e power minus x into cos x by 5 is the yp. So e power minus x cos x by 5. So this is the general solution of the given differential equation when the q of x is e power x into cos x. E power x into cos x. So what's the method we used here? The method 4 we used. So what is the method 4? The method 4 is q of x is equal to e power ax into v of x. So what is the yp to find? The yp is 1 by f of d into q of x. So 1 by f of d into q of x is nothing but e power ax into v of x. So what is the substitution to take here? Put d is equal to d plus a is the substitution. So d is equal to d plus a. So e power ax into 1 by f of d plus a into v of x. So we know that the v of x is either sin ax or polynomial. So if it is a trigonometric function, that is like a sin ax or cos ax, so we have to use the method 2 to find the yp from here onwards. Then if v of x is a polynomial, then you have to apply the method 3 of finding a yp. So this is all about the method 4 by finding a particular integral. So in the next session, we will see the method 5 of finding a particular integral.